Hello, fellow problem solvers. So today we're going to be talking about the three pillars of math competitions. And without further ado, let's begin. So what are the three pillars? They're really the three things that you need for all these competitions. Like, how do you prepare for these math competitions? And I believe this sort of model applies to other areas of life as well. So what are they? Number one is problem solving. To get better, to be able to prepare yourself for these competitions, to do well on these exams, you need to solve many different types of problems. Problems from different areas that may come up, problems with different tricks and tips that may come up, but really problems from different countries, from different levels of competition, so that you may be exposed to different tricks and different ways of applying certain methods. For example, you would need to, say, learn how to apply residues. One problem that you can solve at the beginning is 3 divides a squared plus b squared. Prove that 9 divides a times b. And the way you solve that is by looking at the residues that a and b can have when divisible by 3, when divided by 3. And the answers are, if 3 divides a squared plus b squared, then a and b are forced to both be divisible by 3. Because when you look at the residues, that's what happens. And then you can look at that idea applied there. But then more generally, residues can be applied at 2008 IMO shortlist, problem number N2. Again, you're applying these residues, not quadratic ones, but residues at a higher level. And there are different types of residues, but it's the same idea, same sort of theory sort of thing that you're applying in a different way, in a different context. Quadratic residues may be at 2008 IMO problem number 3. That uses quadratic residues. Really, it's just a higher level. But that's the first pillar. You need to solve problems. And the other pillar is theory, learning theory. Say, if we look at the analogy of number theory, you can learn about the fundamental theorem of arithmetic, divisibility, congruences, and modular arithmetic. And then that's one level of theory. But then you can also learn about the Fermat's little theorem or Euler's tuition function. And that's another level of theory. But the thing is, this Euler function builds up from residues and inverses, but it builds up from there. And it builds up from you learning this. And then this maybe builds up into something else. But the thing about theory is it's a bunch of really sort of shorthands. If you really think about what theory is, because most of these things are built up from simpler concepts, theory is a shorthand, a quicker way of using something that you already know. For example, power of point. That's nothing else really than similarity. Similarity in concyclic points gives you a power of point. Then what is the radical axis? The radical axis theorem is like power of point and adding a point like in the converse sense. That's what the radical axis theorem gives you. So these different things in theory are really combinations of smaller things, and they're shorthand rules or patterns that you see in other problems that you can apply in general. That's what theory gives you. And that is the second pillar that you need to work on. And the third and final pillar of competitive mathematics is your inner game, so to speak. How do you take tests? What is your view of your place in these competitions? How do you motivate yourself to work in these competitions? How do you prepare the day before a competition, the night before a competition, the day of a competition? How do you take the exam? What are your thought patterns while you're taking it? Are you concerned about what people may think of you if you succeed or fail? Are you concerned about the fact that you haven't solved this problem for the last hour and that you only have 2.5 hours left? And how are you going to finish this? How are you going to, how do you deal with these things? And these are the three pillars, like your maybe inner game or psychology, your theory game, like how much do you know stuff? Do you know what projective geometry is and how to use it? Or do you not? And then there's the problem solving part. Now the common pitfalls are that if you feel insecure about your problem solving, you will try to learn a bunch of theory. That is sort of where your instinct may lead you. I don't feel that I'm a great problem solver in, say, geometry. I can't really do well with, I don't do well with these similarity problems or concyclic point problems. I'm going to learn about trigonometry. And you may think that if you know more, like it makes some sense, like if you know more, you can see it as you have more tools at your disposal. Oh, I just need to learn projective geometry. Oh, complex numbers. Oh, I need to learn barycentric coordinates or whatever. It feels like if you know more of these things, then you'll be able to solve more problems. And that is maybe true in some theory. But the thing is, you know a lot of these things when you're learning theory, but you don't know these things very well, which is what hard problems are. A difficult problem in geometry doesn't use 12 different tools, 12 different theories, so to speak. It doesn't use barycentric coordinates and then inversion and then projective geometry and then some similarity and then angle chasing with concyclic points and then you finish it off with radical axis theorem. It doesn't use all of that, but it uses one, maybe two or three of these ideas, at most three I believe, of these ideas in an interesting and ingenious way. That's what a difficult problem is. It's not about you knowing 10 tools. It's about you knowing one or two or three tools very, very well. And what happens is, when you know similarity, for example, very, very well, then other things like, say, homothety, or maybe even not projective geometry, but maybe even trigonometry becomes easier because you have a deeper understanding of the building blocks of your theory. And that's why the first sort of common pitfall is, I don't feel good about my problem solving, let me learn some theory. And the trick there is, if you don't feel confident in your problem solving, if you don't feel like you can solve some of these difficult problems, or these problems that you may think are, you should be able to solve them but you can't, don't tread on that and don't try to learn more theory to be able to solve this, but rather solve easier problems. Build up your knowledge by solving easier problems so you can build up to these more difficult problems. If you're trying to solve an IMO G8 off the bat, you're gonna have a bad time. But if you start with a G1, then you might be able to build up there. And if that's too hard, look at some team selection tests. Look at the team selection test geometry problem that was a first geometry problem, say, in the United States, or in Brazil, or in France, or Romania, or Russia, or China. And if that's difficult, try to solve a team selection test from a country that performs weaker at the IMO. Say, look at the team selection test of Bosnia. Look at a team selection test of Estonia, Norway. Look at some of these team selection tests, which are easier and have easier geometry problems. Take it down a notch. If that's too hard, take it down a notch again. Maybe start with junior level competitions, Junior Balkan Math Olympia. And if you have the patience to build up from these easier competitions to these more difficult ones, then you're going to have a much better time progressing because you'll be building up an intuition for how you're going to solve more difficult problems. And with that being said, that's the first pitfall. And now there's another pitfall, which is that you may focus so much on your inner game, your psychology, that you forget how to do math. I'm talking about these pitfalls because I was in them. And you may just try to focus on everything. How do I motivate myself? Trying to perfect your routine, your concentration, trying to learn more about your psychology. But really the thing is, there's a couple of things that you need to get good at. One is that you need to learn how to deal with these pressures and stresses of the competitions. There's many different ways. I'll make a video about it in the future. And you need to find ways to motivate yourself. And you need to find ways that you're going to take the test. Like, how are you going to take the test? You need to create a strategy for how you are going to be taking these exams. That's pretty much most of what you have to deal with here. Set your goals, solve a lot of problems, and when you can't solve them, learn the theory. And this also applies to other things. If you have, say, you want to learn to play basketball, you have the theory behind how you are going to make a shot, how you should shoot, how do you pass the ball and whatnot, but you also need to play the game. And if you're just looking at videos, analyzing how different muscles work when you're making the shot, but you never really take a shot, then you're not going to progress as fast as if you also, you take a shot, a bunch of shots, you reach sort of a plateau, then you learn some theory. How can I take better shots? Maybe I don't throw the basketball like this, but I try to throw it like this. And then looking at, how do I position my body? But you do that, not from the get-go, but you first, you shoot a bunch. You see, this is a bad way to shoot. This is a good way to shoot. And then after you've shot a bunch of shots, you shoot some more. You see the ball isn't always going in. Then you find some more theory, look it up, and you see, I need to position my body differently. I need to jump differently when I'm making the shot. And then you practice that. And the inner game, if you're always just trying to think, okay, how do I deal with the pressure of the competition, with the game? How do I communicate? What is a good way to communicate? And you try to watch videos on leadership communication. But if you never ever played a game, you can't really test out this psychology part you've had. You need to solve problems. You need to play the game. And that's really the sort of mental model I'm trying to present to you about how to go about doing these things. These are the 3 pillars. Be aware these pillars exist, and also be aware which one you are working on at the moment. And as always, thanks for problem solving.